Hey you guys, welcome back to another video. This is topic 1.8, rational functions and zeros. Recall that a rational function is a function that is a ratio of two polynomial functions. Think fractions. For example, f of x equals 2x minus 3 divided by x squared minus 4x minus 45. The most important thing is that there needs to be at least one x value in the denominator. Here we have a few. Another example would be something as simple as 1 divided by x. So again, the numerator is not that important. The numerator can have a constant number, but for it to be a rational function, the denominator must have at least one variable. We explored polynomial inequalities previously in topic 1.5, and we can utilize some of those concepts to help us understand more about rational functions like f of x. Two important traits of a rational function. Let f of x equal g of x divided by h of x be a rational function where g of x and h of x have no factors in common. I'm going to zoom into this part right here. No factors in common. You might have learned this in Algebra 2, but if there are factors in common, then they're going to cancel out. So common factors cancel out, and they create wholes. Okay, so for example, let's say we had x minus 2, x plus 3, x plus 5, and x minus 2. So you see how we have two common factors. We have x minus 2 and x minus 2 in the numerator and the denominator. These two would cancel out and there would be a whole here. And you would set that factor equal to 0, so you would do x minus 2 equals 0, and the whole would be at positive 2, at x equals positive 2. Okay, so after you cancel out any common factors which would create wholes, then we know that f of x has zeros when g of x equals 0. And g of x here is in the numerator, so all you need to do to find the zeros is set the numerator equal to 0. So on this example here, we had, after you cancel out the 0, we have one remaining factor in the numerator. So you would, to find the 0, set that factor equal to 0, and then solve for x. You would get a 0 at x equals negative 3. Okay. For trait number 2, f of x is undefined when h of x equals 0. Notice that h of x is in the denominator, so when you set the denominator equal to 0, you get the values where it is undefined. Okay, so there are two types of discontinuities in rational functions. You can have wholes and you can also have vertical asymptotes. So they both occur when the denominator equals 0, but if any of the factors do not cancel out with any factors in the numerator, then you get vertical asymptotes. Okay, so on this one, the remaining factor in the denominator was x plus 5. So we would be able to find the vertical asymptote by setting that factor equal to 0. And we would get a vertical asymptote at x equals negative 5. Okay, so again, the first step is see if there's any wholes, if there's any common factors in the numerator and the denominator, those would cancel out. And then whatever you have remaining in the numerator, that factor or factors are your zeros, and whatever you have remaining in the denominator, those factors would be your vertical asymptotes. Okay. When solving rational inequalities, you need to identify both the zeros and the undefined values. So make sure the inequality has 0 on the other side. Make sure that f of x equals g of x divided by h of x. So make sure you have a single rational function. You shouldn't have something like 1 plus x divided by 5x squared. You should have just one singular fraction. And then you're going to set the numerator equal to 0, the denominator equal to 0, and you're going to find the values to include on your sign chart. Now, if you need to factor, we have 3 factoring methods that we've talked about before. So one method would be the greatest common factor. The second method is the difference of perfect squares. And the last method would be X method. If you still need help factoring, I do have a factoring video somewhere on my channel. Okay, after you get all of those values, you're going to create a sign chart with all the values from step 3, and then you're going to be careful to mark the values where h of x equals 0 so that you never include those values in the solution. You're going to test values in each interval to see if the values in the interval are positive or negative. If they're positive, you're greater than 0. If they're negative, you're less than 0. And then you're going to interpret the sign chart to answer the given inequality from the problem. Be sure to write your answers in interval notation and think about the endpoints. So when you're doing interval notation, if you have just less than or greater than, you're going to be writing your answers with parentheses. And if it's less than or equal to or greater than or equal to, you're going to write those numbers in brackets. Now, on the number line, I'm going to have you put open and close circles depending on if something is included or not included. So if it's not included, I want you to put an open circle. And if it is included, I want you to fill in that circle. Okay. So back to this step here where it said, make sure to mark the values where the denominator equals 0. I'm going to put 2 little notes there. Okay, so for the zeros, which are from the numerator, you're going to put either an open or a closed circle depending on the sign on the question. Okay, for the vertical asymptotes, you're always going to put an open circle. And these are the values from the denominator. Okay, so let's get started with some examples. So example 1, x minus 2 divided by x plus 6 times x minus 3 is greater than or equal to 0. To start off, I understand that this problem is asking me to find where the y values are positive, and I'm also going to include the zeros. Okay, so the first thing I'm going to do is solve for the zeros, and I'm going to solve for the vertical asymptotes. My zeros come from the numerator, which I only have one factor of, and my vertical asymptotes would come from the denominator, and I'm going to set those factors equal to 0. We didn't have any holes here, nothing canceled out, so we just have zeros and vertical asymptotes. So I have a 0 at x equals 2, and 2 vertical asymptotes at x equals negative 6 and x equals positive 3. At this step, you're going to create a number line. All the way to the left and to the right, you have negative and positive infinity. And on your number line, you're going to place these numbers in increasing order. So the smallest one was negative 6, then we have 2, and then we have 3. Now, remember the zeros, you're going to put either an open or a closed circle depending on the sign on the question. So those are the zeros from the numerator. So depending on the sign of the question, this said and the zeros, it's greater than or equal to. So whatever I got from my numerator, this 2 needs to be included. So I'm going to make sure I remember that by putting a little closed bubble on the value of 2. But we said that the vertical asymptotes, whatever values were from the denominator, you're always going to put an open circle. The reason you always put an open circle is because you never touch vertical asymptotes. If you can never touch them, that means you can never be equal to them. So you'll never have a bracket, or it's basically never going to be included because you never touch it. Okay, so at this point now you're going to put test values. So anything that comes before negative 6 would work. We could do negative 10. You could have done negative 7, negative 8, negative 9, negative 10, negative 20. It doesn't matter what number you pick as long as it comes before negative 6. In between negative 6 and 2, I'm going to select 0. There's a lot of numbers you could have picked there. You could have picked negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. But when I have the option to pick 0, I pick 0 because it makes the process faster. Between 2 and 3, I'm going to select 2.5, and after 3, I'm going to select 4. Okay, so what we're going to do with these values is plug them into our factors up here. So negative 10 minus 2, that would give me negative 12, which is a negative. I don't really care about the actual digit that I get. I just want to know if it's positive or negative. Okay, negative 10 plus 6 would be negative 4, and negative 10 minus 3 would be negative 13. So here I have 3 negatives, which is going to end up being negative. So remember, if you have an odd number of negatives, it's going to end up being negative. And if you have an even number of negatives, it's going to be positive. So here I had 3 negatives, which make a negative. Okay, moving on to the zeros. 0 minus 2 is a negative 2. 0 plus 6 is positive 6. And 0 minus 3 is negative 3. You see I have an even number of negatives this time. There's 2 negatives. Those are going to make a positive. Okay, 2.5 minus 2, that would be a positive 0.5. 2.5 plus 6 would be 8.5. That's another positive. And 2.5 minus 3, that would be negative half. So I have an odd number of negatives this time because there was only one. So this interval will be negative. Okay. Moving on to 4 minus 2, that would be positive 2. 4 plus 6 is 10. 4 minus 3 is 1. All of them are positive, so this interval is going to be positive. Now, remember the question wanted where y is positive. So what I'm going to do now is box in the intervals where I ended up with a final sign that is positive, which are these here. And these are going to be the numbers I'm going to include on my intervals. Okay, now you want to make sure that in your intervals, you should only be including the numbers that you solved for from your zeros and your vertical asymptotes. Please do not use the test values. That was just to help us figure out if it was above or below the x-axis, but they're not what is going into the intervals. They should be the values you solved for x in the previous step. Okay, so here we have negative 6 with an open circle, so I know negative 6 will have to be a parentheses. And then I went all the way to 2, but 2 is closed, so I know closed bubbles use brackets. And because there's more than one interval, I'm going to put the union symbol. Then next time I'm positive, I start at 3, but the open circle prompts me to use a parentheses. And then all the way to the right, I am going to infinity. And infinity always uses parentheses, no matter what, because we cannot equal infinity because we don't know the value of infinity. Okay, so the intervals where this function was greater than or equal to 0 is negative 6 to 2, union 3 to infinity. And because these two vertical asymptotes are open, that's why the negative 6 and the 3 have parentheses there. Okay, let's try another one. Now, what I see about example 2 is that it is not factored. So I'm going to have to factor it before I get started. If I look at the numerator, I see that I can use the difference of perfect squares. So I can square root the x squared and square root the 4. And then I'm going to end up with x plus 2 and x minus 2. Okay. For the denominator, I need to think of two numbers that multiply to positive 25 and add to negative 10. Those numbers could be x minus 5 and x minus 5. Okay. Now, I'm looking at this and I can see that I can simplify it further because in the denominator, I have two factors that are exactly the same. So what I can do is rewrite the numerator, x plus 2, x minus 2. And I know that when two of the same things are multiplied together, that just means that it's being squared. So I can write x minus 5 squared, right? The same thing as 5 times 5 is 5 squared. X minus 5 times x minus 5 is x minus 5 squared. Now, this is not a necessary step. If you don't simplify it that far, you're still going to get the right answer. I just prefer to do it this way if I can because I know that anything that is squared is always going to be positive. So it helps me when I'm plugging in values. I don't need to plug it into two separate factors and then multiply those together. It's easier if I know this is squared because no matter what, this will always be positive, right? Because if I have 4 times 4, that's going to be a positive 16. If I have negative 4 times negative 4, it's still going to be positive 16. So it doesn't matter what I plug into this, because this is squared, the outcome will always be positive. So it saves me a little bit of time in the next step when we do the number line. Okay, now the question was asking us, when is this function less than 0? So we're looking for where y is negative, but we are not including the zeros because it did not say less than or equal to. Okay, so now let's solve for the zeros by setting the numerator factors equal to 0. So we have x plus 2 equals 0, x minus 2 equals 0. And then for the vertical asymptotes, we have x minus 5 squared equals 0. Okay, here we get x is equal to negative 2, x is equal to positive 2. After you square root this, you get x minus 5 equals 0, and so x would be equal to positive 5. Okay, so after this, we're going to create our number line. And you're going to put your values in order from least to greatest, making sure to include the negative and positive infinity on either side. Okay, so the smallest one was negative 2, then we had positive 2, then we had positive 5. Now, in the numerator, remember, let me go back. For the zeros, you're going to put either an open or a closed circle depending on the sign from the question. This question we said did not include the zeros. There is no equal to at the bottom. So these values from the numerator will have to be open. So the negative 2 and positive 2 are open. Now for the denominator, for the vertical asymptote, we said always put open circles on the values from the denominator. So from the denominator, we got x equals 5. So that x equals 5 will always be open no matter what. All right, let's pick some test values. Before negative 2, I can pick negative 3. Between negative 2 and 2, I can pick 0. Between 2 and 5, I can pick 3. And after 5, I can pick 6. Okay, those test values, you could plug them into the unfactored form, the factored form, or the super factored form. Okay, it doesn't matter. Since on the AP test though, you do not have a calculator, I would not recommend for you to plug it into this one. You can, but you're probably more likely to make a few mistakes. So if you get this far, like let's say you didn't realize that you can make this one squared, you can absolutely use this one and get the correct answer. However, I'm going to be using this one, my most simplified form. Okay, negative 3 plus 2 is a negative 1. Negative 3 minus 2 is negative 5, and I know that anything that is squared is positive, so I'm not even going to waste my time to plug it in. Okay, 0 plus 2 is positive, 0 minus 2 is negative, and the denominator is always positive because the factor is squared. All right, so now we're going to plug in the 3. 3 plus 2 is positive, 3 minus 2 is positive, and the denominator is always positive. 6 plus 2 is positive, 6 minus 2 is positive, and the denominator is always positive. So now we're going to see what the final intervals were. In the first one, we have 2 negatives, that's an even number, so it'll be positive. On the second interval, we had 1, which is an odd number, so it'll be negative. And the last two, there were no negatives, so those will be positive. The question was asking for where y is negative, so that's only going to be this interval here. And remember, do not use the test values when you're writing your answers. They need to be using these x values that you solved for at the beginning, okay? So I see the first number is a negative 2 with an open circle, so I know that's going to be using a parentheses. And then it goes to positive 2, also an open circle, so another parenthesis. So the final answer is just negative 2 to positive 2, okay? Let's go to the next page. We're going to try some more examples. Here, we do not have any factors in the numerator. We just have a positive 2. If you were to pretend that we're solving for it. Anyways, I'll show you in a minute. Sorry, not the 0. Sorry, my cat is hovering around me. And then for the vertical asymptotes, you set the denominator factors equal to 0. Now, if you look back at the zeros, 2 equals 0, that will never be true. So you don't have to worry about that. This one does not have any zeros, but it does have a vertical asymptote at positive 3. So then you create your number line. On the outskirts, you're going to put negative and positive infinity. And in the middle, since we only have one x value, we're going to put 3. But remember that everything that comes from the denominator, which is your vertical asymptote, will always be open. So I'm going to annotate that vertical asymptote with an open hole. Before 3, I can test the number 0, and after 3, I can test the number 4. Now, I cannot plug a 0 into 2 because the 2 is a constant number. It has no variable. That means that the numerator will always be a positive 2, no matter what. Okay, 0 minus 3 is negative. A positive divided by a negative is a negative. Again, on the other side, the 2 is always a positive 2. You cannot plug anything into it to change the sign of the 2. And then 4 minus 3 is a positive, and 2 positives make a positive. The question was asking us to find where y is positive, and this is not including the zeros, which we didn't even have zeros, so that doesn't matter. Not including zeros. So the intervals where we were positive are 3 all the way to infinity. And the 3 had an open circle, so I know it's going to be parentheses, and infinity is always parentheses. So my final answer is 3 to infinity. Okay, let's try example 4. Example 4, I can factor that numerator using the greatest common factor, so I can rewrite this as 4 times x plus 2. The denominator cannot be factored. It's already factored for us, x plus 5. Okay, and we're trying to figure out where this is less than or equal to 0. So we're going to find out where y is negative and include the zeros. Okay, so first step is to set the factors in the numerator equal to 0. So we have 4 equals 0, and we have x plus 2 equals 0. And then for the vertical asymptotes, anything that's in the denominator, which is x plus 5, set that equal to 0. Just like the other one, 4 cannot equal 0, so you're not going to include that number on your number line. And then here we have x equals negative 2, and here we have x equals negative 5. So we're going to create the number line now. Put positive and negative infinity on either side, and put your values in order from least to greatest. So the smallest number here is negative 5, and then negative 2. Okay, so remember, for the zeros, whatever is in the numerator depends on the inequality. Because the inequality said and the zeros, we said that earlier, and we're including the zeros, this value that we got for the 0, which is at negative 2, will be closed. So I'm going to put a closed bubble around negative 2. And then remember that everything from the denominator, which are your vertical asymptotes, are always open no matter what. Now let's test some numbers. I'm going to test negative 6, negative 4, and 0. Okay, now I'm going to be plugging it into this one. You can plug it into that one as well. It's your choice, but I'm going to be using this one. Okay, that 4 in the front is always going to be positive because it's just a positive 4. It's a constant number. And then negative 6 plus 2 is negative, and negative 6 plus 5 is negative. An even number of negatives will be a positive. Okay, the next interval, we have a positive 4 that never changes. Negative 4 plus 2 is negative, and negative 4 plus 5 is positive. So this interval has an odd number of negatives, so it'll be negative. Next, we have 0. The 4, the positive 4 never changes. 0 plus 2 is positive, and 0 plus 5 is positive. So this whole interval is positive. We were looking for where y is less than or equal to 0. So I'm looking for the interval where we ended up with a minus, which is this one here. And when I write my answer, I see the negative 5 has an open circle, so it'll be parentheses, negative 5, and then it went to negative 2, which is closed, so the negative 2 will have a bracket. Okay, so negative 5 to negative 2 is the final answer. Let's move on to example 5. This one is already factored for us. All right, let's find the zeros first by setting all the factors in the numerator equal to 0. And then we're going to find the vertical asymptotes by setting the denominator equal to 0. Here I get x equals positive 1. For the second factor, you square root it to get rid of the square, and then you end up with x plus 2 is 0, and finally x equals negative 2. And for the vertical asymptote, you get x equals positive 2. Okay, we're going to make our number line. Don't forget to put positive and negative infinity. Put your numbers in order from smallest to greatest, so negative 2, 1, and 2. Now the question we're being asked is, where is y positive? And we're going to include the zeros. So if we're including the zeros, which I got, we're at 1 and negative 2, that means that these numbers will have closed bubbles on them, closed circles, okay? And the vertical asymptote, which is what we got in the denominator, is always open no matter what, so the positive 2 will be open, okay? Let's test some numbers. I can pick -3, 0, 1.5, and after 2, I can pick 3, okay? And I'm going to be plugging it into the factors at the top. -3 minus 1 is negative. A factor that is squared is always positive, and -3 minus 2 is negative. I have two negatives, which will be a positive. 0 minus 1 is negative. The one that is squared is always positive, and 0 minus 2 is negative. So this interval will also be positive. 1.5 minus 1 is positive. The factor that's squared is always positive. And 1.5 minus 2 is negative. We have one negative, which will make this whole thing negative. 3 minus 1 is positive. The factor that is squared is always positive. And 3 minus 2 is positive. Three positives make a positive. Okay, we were looking for the intervals where y is positive. So we have this interval here, this interval here, and this last one over here. Okay, so now to write our answer, we start with negative infinity in parentheses. Now we could stop here, but because it is closed in the middle, you are able to go all the way over. Okay, if this was open, you would have to stop, but because we're including the zeros, that allows us to go all the way to +1 with a bracket because 1 is closed. And then we'll do union. The 2 has an open circle, so I'm going to put a parentheses, and then it goes to 2 to infinity. Okay, so this is the final answer. Again, just as an example, if the question was, let's say it was just greater than 0 and not equal to 0, then the answer would be negative infinity to -2 parentheses union -2 to 1 parentheses union 2 to infinity. So the only reason that you can go all the way through here is because this bubble was closed. If it was not closed, you have to stop at the zeros. So you would have to stop at the -2. You would not be able to go all the way to 1 if the interval was not including the zeros. Okay, let's try one more example. We're going to find the zeros by setting the numerator equal to 0. Sorry, my pen glitches sometimes. I don't know what it's doing right now. 1 equals 0, and then for the vertical asymptotes, we have x minus 1 squared equals 0. Okay, 1 does not equal 0, so we have no zeros on this question. And for the vertical asymptote, I need to square root the factor so I can get rid of the square. And then we have x minus 1 equals 0, which gives me x is equal to +1. Now I'm going to create a number line. I have no zeros. The only value I have is 1. And because it is from the denominator, it is a vertical asymptote. It'll always be open. Okay, I'm going to test 0 and 2. Now that 1 in the numerator, it doesn't change. I cannot plug anything into it. It just will always be a +1. And then any factor that is squared is always positive. For the other side, 1 is always positive, and the factor that's squared is always positive. These do not have any negatives, so both of the intervals are positive. Okay, let's see what the question was asking us for. They said find where y is negative, y is less than 0, and include the zeros. Well, we didn't even have any zeros, and we also don't have any intervals where we were negative because both of our intervals are positive. So the answer for this is that this function is never less than or equal to 0. It is always greater than 0. Okay? So let's try some examples where we do inequalities when you're looking at a graph. Okay? Let's start with letter A. F of x is less than or equal to 0. I know that that just means that y is less than or equal to 0, so that means that it is below the x. Hold on, let me erase this. It is below or on the x-axis. Okay, And then if it helps you to think of it as y is negative or 0, you can think of it like that as well. It's the same thing because below the x-axis is where your y values are negative, where they are less than 0. And then on the x-axis, they are exactly equal to 0. So what I'm going to do first is locate my zeros, which are at -1 and +2. And I'm going to trace in this blue color everything that is below the x-axis where the y values are negative. Okay, now a common misconception is that this interval would be -infinity to -1. However, this graph does not go all the way here. As you can see, it's actually going straight down like this, and the reason for that is because we have two vertical asymptotes. So what I'm going to do now is label these vertical asymptotes. We have two. Now this one, they gave you dashed lines. They do not always have to do that, so don't get used to that. You need to sometimes find the vertical asymptotes on your own. But we have two vertical asymptotes at x equals -3 and +3. And remember that you cannot cross a vertical asymptote, so this blue graph will be incapable of going to -infinity because it is bound by that vertical asymptote. So in reality, this graph is not going any further than -3. So we're going to start our interval saying -3. It cannot go any further than that. And the reason I put a parentheses is because you don't touch the vertical asymptote. Remember, vertical asymptotes always use parentheses. I'll make a note of that. Vertical asymptotes always use parentheses. Okay, and after -3, I go to -1, and because this question was including the zeros, I'm going to use a close bracket, union. The next part that I annotated in blue was a 2, which I closed because it is a 0, so the 2 will have a close bracket. And just like the other one, this one cannot go to +infinity because it is bound by the vertical asymptote, and it will never go past the vertical asymptote at 3, and vertical asymptotes always use parentheses. So this is my final answer, -3 to -1, union 2 to 3. Okay, let's try another one. F of x is greater than 0. That means I am above the x-axis. And if it helps you, all that's saying is that y is positive, right? Where is y positive? Well, that's above the x-axis. So you can think about it any way you want. Now, this is not including the zeros. So even though we included these zeros in the last question, for this, this iPad, I don't know if it's the pen or the screen. For this question, we will not be including these zeros, okay? And then we are including everything that is above the x-axis, so I'm going to trace everything above in pink. Okay, so my answers are going to include only the stuff I have in pink. So starting all the way to the left, remember you do your intervals from least to greatest. So starting at the left, I see that the pink graph goes to -infinity. And then again, I am bound by that vertical asymptote at -3. Okay, so notice this graph will go up forever because of this vertical asymptote. So I can't go past 3. The next time I see pink is at this -1, but because we are not including the zeros, the -1 will have a parentheses this time. And then it goes to +2. Again, we are not including the zeros. And then union. And then after this vertical asymptote at 3, I get another part of the graph that then goes all the way to the right to +infinity. Okay, so 3 to infinity. So that's my final answer. Let's try one more. F of x is greater than or equal to 1. So that's asking me, where is y greater than 1 or equal to 1? Okay, so let's look at the graph. The only thing I see at y equals 1 is this vertical asymptote. A horizontal asymptote at y equals 1. So what this question is really asking me is, when are we above the horizontal asymptote? Okay, So above the horizontal asymptote, I'm going to ignore everything that's below the horizontal asymptote at 1, and I'm going to trace this one in this lavender color. Okay, so that would just be the very far left and far right of the graph. Okay, we are not, here's the horizontal asymptote, we are not going to be including any of this over here. We are not including this little part or anything below. Okay, it is strictly what I have in purple, whatever is above the horizontal asymptote, which are where y is greater than or equal to 1, right? So that is this horizontal asymptote. So all the way to the left, we start at negative infinity. We are again bound by that vertical asymptote at -3 with a parentheses, union, and the next time I have purple is over here. Remember, we are not including this part. We start again after the vertical asymptote at +3, and then the graph keeps going on to positive infinity. Okay, so this is the final answer. These are all the notes. Let me know if you guys have any questions, and I'll see you in the next video. Bye.